22.3, solving quadratic equations using the quadratic formula. So one of the things you'll hear in class with this lesson is a song on how to remember the quadratic formula. But mainly this is the reason why completing the square is not as important in terms of how to solve equations. Now with quadratics we have talked about a little bit how sometimes you get answers that are irrational. You don't get exact numeric values, decimals or fractions or integers. So with completing the square you're using square roots, but quadratic formula incorporates the square root. So that's really how we want to solve quadratics when they're not factorable or not exact values. So how do we do that? Well, first of all, we need to see what the quadratic formula is. So it's right here at the top. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the implementation of the quadratic formula can only be done when a quadratic equation is written in standard form. So that is ax squared plus bx plus c, standard form. Also, quadratic formula can only be used when the equation is set equal to 0, a major difference, again, in solving by completing the square. And this is why, again, completing the square is not a big deal as far as learning how to solve, because everything to this point we've learned has been setting it equal to 0, and then either factoring, taking the square root like in 22.1, or in this case, using the quadratic formula. Now, there's a part of the quadratic formula that is referred to as the discriminant. Okay, the discriminant is the part that's under the square root. It's the b squared minus 4ac. Now, the reason that's important is because the value of the discriminant, if we go back and look up here under the square root, if the value of the discriminant is 0, then all of this right here goes away, which means our plus minus goes away. Well, if our plus minus goes away, that means it has only one solution. And remember, we referred to this back in Module 21 as a double root because it's the same answer used twice. If the discriminant is a positive number here, then we're getting the square root of a positive number, which means we have a plus or minus case, which means we have two unique solutions. They're not the same one. And then the last case is when the discriminant is a negative. Well, we can't take the square root of a negative number. That's called imaginary, and you'll deal with imaginary numbers when you get into Algebra 2. But graphically, what that means is that the parabola on a graph does not cross the x-axis. Therefore, it has no real solutions, again, referred to as imaginary. So, in this particular lesson, we're going to learn first how to find the value of the discriminant, what it tells us about the types of solutions we have, and then how to solve using the quadratic formula. So first of all, we're going to do the discriminant portion. So in this case, I'm going to do problem number 4 of the your turn. The first thing you want to do is identify your values. Again, always make sure it's in standard form, ax squared plus bx plus c equals 0. So in this case, our a is 2, our b is negative 6, and our c is 15. Again, the discriminant, I'm going to write the quadratic formula here on the left. The formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the song that we'll sing tomorrow in class with this is Goes to Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So hopefully you're familiar with that tune. But it helps you remember what we're focusing on here is the discriminant, the part under the square root. So over here, back on problem 4, I need b squared minus 4ac. Now, whenever you're doing substituting values, always put them in parentheses. So in this case, b was a negative 6 minus 4. A here was 2, and c was 15. So we're going to simplify that. That's 36 minus, if you do this, that's 8. 8 times 15 is 120. 36 minus 120 would be a negative 84. Now, because it's a negative, again, referring back up here, you cannot take the square root of a negative number. Therefore, for this particular problem, the value of the discriminant is negative 84, and it has two imaginary roots. Okay? Now, what this book is going to refer to, since we're not dealing with imaginary, it's going to say it has 0 real roots. If they're imaginary, they can't be real. So this one has 0 real roots. Now again, what that means graphically is the parabola does not cross the x-axis. This is a reference to the calculator and how the calculator can help in determining whether or not your answers make sense and if they're truly correct by using a quadratic formula. What we're going to do is actually go to the quadratic formula here and do it for a problem. So in this case, I'm going to do problem 8. Let's do one where it's not set equal to 0. So the first thing you got to do is make everything equal to 0. So remember, standard form, ax squared plus bx plus c equals 0. So here I'm going to move that over, and I'm going to move that over. So when I move the 8x over, it now becomes a negative 8x. When I move the 7 over, it becomes a positive, and now all that's equal to 0. So here, a is 2, b is negative 8, c is 7. So the first thing I'm going to do is just go ahead and find the discriminant part. So the b squared minus 4ac. So if I do that, this is going to help me determine, first of all, what kind of solutions it has. So again, whenever you substitute a value, always put it in parentheses. Simplify, so we get 64 minus 56, which is 8. Okay, now because that's a positive, that means this is going to have two real roots. So now what I'm going to do is come over here, quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's the song again. What I've done is I've already found the discriminant. That's 8, so I can go ahead and plug it straight into the formula. So now I have x equals negative, okay, b again, whenever you substitute, put it in parentheses, plus or minus the square root of 8, because that was my discriminant I found earlier, all over 2 times 2. So I simplify, and I get 8 plus or minus 8, because a negative and a negative make a positive again, plus or minus. Now, 8 you need to break down. Perfect square in 8 is 4. This takes us back to module 22.1, simplifying radicals, all over 4. Square root of 4 is 2, so that 2 comes out. It's no longer under the radical. So now I have 8 plus or minus 2 square root of 2 all over 4. Now, what will go into all those? 2 will go into those. 2 will go into 4 2 times. 2 goes into 2 once. 2 goes into 8 4. You cannot do the 2 under the radical because you can't divide in the square root there. So what I'm left with is 4 plus or minus square root of 2 all over 2. Those would be my two solutions. Now, you can write them independently. You can also do them on the calculator and check the decimal values to see if they match up with the graph on the calculator. But if you graph this particular function equal to 0, so if you put this back in as y1, you're going to see it crosses the x-axis at 2 places. Those 2 places are decimal values that relate to the solution by quadratic formula. So again, this is application using word problems. We're going to go ahead and just go to the homework itself and focus primarily on how you determine what type of solutions it has by doing the discriminant. That's what this is about. And actually using the formula itself to solve. Now it says leave answers that are not perfect squares in radical form. That means leave them in square roots, but you have to simplify the square root. and we'll focus on that, and we will do assignments out of the book on this particular one.